Hello everyone, welcome back to the BlackHat Path. In the previous video, we learned how websites work and even hosted our own website using Apache on Kali Linux. Now it's time to understand something every ethical hacker, penetration tester, and bug bounty hunter must know: the OWASP top 10. Imagine this, that every day thousands of websites are attacked. Some attacks steal passwords, some leak sensitive customer data, and some even allow attackers to take complete control of a web application. But here's something interesting. Most of these attacks don't happen because hackers are using magical tools or secret techniques. These happens because developers make common security mistakes. OWASP studied thousands of real-world attacks and identified the 10 most critical web application security risks. These are known as OWASP Top 10. Today's goal isn't to teach you how to attack websites. Instead, we are going to understand what these vulnerabilities are, why they exist, and how security professionals protect against them. So let's begin. Let me ask you a simple question. Have you ever heard news about millions of user accounts being leaked, or companies announcing that the customer information has been stolen? You might wonder, how does something like this ever happen? The answer is that the most successful cyber attacks don't happen randomly. Attackers usually exploit known security weaknesses that already exist in web applications. For example, imagine an online shopping website. If a customer can simply change one number in the URL and access someone else's order details, that's a serious security flaw. Or imagine a website storing passwords in plain text instead of encrypting them. If the database gets stolen, every user's password is immediately exposed. These are not imaginary situations. They have happened many times in the real world. That's why OWASP exists. Instead of waiting for organizations to repeat the same mistakes, OWASP documents the most common and dangerous vulnerabilities so developer and security professionals know what to avoid. As ethical hacker, our job isn't just to find vulnerabilities, it's to understand why they occur and help organizations fix them before attackers take advantage. So before learning offensive security techniques, we first need to understand the risk we are defending against. Now that we know why web security is important, let's understand what OWASP actually is. OWASP stands for Open Web Application Security Project. It's a non-profit organization dedicated to improving software security around the world. One of the best things about OWASP is that it shares the resources completely free of cost. Whether you are a student, developer, security researcher, or penetration tester, anyone can learn from its documentation. OWASP creates security standards, testing guides, secure coding practices, educational material, and one of the most famous publications, the OWASP Top 10. You can think of OWASP Top 10 as a cybersecurity's most wanted list of web application vulnerabilities. It isn't a list of every possible attack, instead, it focuses on vulnerabilities that are most common, most dangerous, and have the greatest impact if left unfixed. This list is updated periodically to reflect how web security changes over time. As new technologies emerge and attacker evolves, OS updates its recommendations accordingly. That's why understanding the OS top 10 is considered one of the first steps in learning web application security. Now let's start with the number one risk in the OS top 10: broken access control. Imagine you logged into the bank account and open this page: bank.com, account ID is equals to 105. Now suppose you simply change the number to 106 instead of 105, and suddenly you are looking at someone else's bank account. That would be a disaster. This happens because the application failed to verify whether you actually have permission to access that resource. Access control is simply the process of deciding who is allowed to access what. For example, a student should only see their own grades. Customers should only access their own orders. An employee should only access files they are authorized to view. If those permission checks are missing or implemented incorrectly, users may gain access to data they should never see. Sometimes, attackers don't even need advanced hacking skills. Simply modifying a URL, changing an account number, or altering a request can expose sensitive information. Broken access control can also lead to privilege escalation. Imagine a normal user suddenly gain administrative privileges because the application didn't properly strict access. That's why OS considers the most critical web application security risk. The key lesson here is simple. Never trust the user. Every request must be verified on the server before access is granted. Now let's move to the second vulnerability, security misconfiguration. Imagine you buy a brand new house, you install expensive locks, security cameras, and an alarm system. But before leaving for vacation, you accidentally leave the main door unlocked. All those security measures become useless. That's exactly what happens with security misconfiguration. Sometimes developer builds secure applications but forget to configure them properly before deployment. For example, many systems come with default usernames and passwords. If these credentials are never changed, attackers can log in using public node information. Another common mistake is leaving debug mode enabled. Debug mode is useful while developing softwares because it provides detailed error messages. But if it is left enabled in production, attackers may learn about the server path, database structure, programming languages, and internal application details. Another example is exposing a directory listing. Instead of showing only the website, the server accidentally displays all the files stored in the folder. This can reveal backups, configuration files, or sensitive documents. Missing security hiders, unnecessary services running on the server, or unused software that hasn't been removed can also create opportunities for attackers. The important thing to remember is that security isn't just about writing secure codes. A perfectly coded application can still become vulnerable because of poor configuration. That's why organizations regularly review and harden their server's configuration before deployment. Now, here is an interesting question. What if the software you trust becomes the source of the attack? Modern applications rarely consist of codes written by one developer. Instead, they rely on thousands of third party libraries, frameworks, plugins, and dependencies. These components save time and make development easier, but they also introduce risk. Imagine you are building a house using bricks supplied by another company. If those bricks are defective, your house becomes unsafe even if your construction work is perfect. Software works the same way. If one trusted dependency contains a vulnerability, ours is intentionally compromised. Every application using it may also become vulnerable. One of the most famous examples is the SolarWinds attack, where attackers compromised trusted software update. Organization installed the update because they trust the vendor, unknowingly allowing attackers into their network. This type of attack shows that sometimes hackers don't need target directly. Instead, they attack the supplier. That's why organizations verify software updates, monitor dependencies, and regularly update vulnerable components. Trust is important, but in cybersecurity, trust must always be verified. Now, let's move to next. Have you ever visited a website and noticed how your browser displaying not secure next to the address bar? That's often a warning related to cryptography. Cryptography is the science of protecting information by converting it into the secure form that unauthorized people cannot read. Think about the information you enter every day: passwords, credit card details, bank account information, personal messages, and medical records. Would you want all of these traveling across the internet as plain text? Of course not. That's why websites use HTTPS instead of HTTP. HTTPS encrypts communication between your browser and the website. If encryption is weak or missing entirely, attackers may intercept sensitive information while it's being transmitted. Cryptographic failure can also happen when passwords are stored without proper hashing, encryption keys are poorly managed, or outdated encryption algorithms are still being used. Even the strongest application becomes dangerous if sensitive data isn't properly protected. Remember this: protecting data isn't enough, it must be protected correctly. Now we come to one of the most famous web application vulnerabilities of all time: injection. Imagine a website has a login page asking for a username and a password. Normally, the application sends you input to the database to verify your credentials. But what if the application blindly trusts everything you type? Instead of entering a username, an attacker enters a specially crafted input like this. If the application fails to validate this input, a database may interpret it as a part of command instead of normal text. In some properly designed applications, this can allow attackers to bypass authentication, access sensitive information, or even manipulate the data. SQL injection is one of the best known examples, but injection attacks can also target operating system commands, LDAP queries, XML processors, and other interpreters. The root cause is almost always the same. The application accepts untrusted input, and executed without proper validation or sanitization. This is why developers use techniques such as parameterized queries, prepare statements, input validations, and secure coding practices. Injection teaches us one of the most important rules in cybersecurity. Never trust user input and always validate it before processing it. And that's the first 5 vulnerabilities of the OWASP top 10. In the next video, we will cover the remaining 5 vulnerabilities and see why they are equally important in web application security. Until then, revise these concepts well because they will help you in understanding the practical topics coming next. I will meet you in the next video. Till then, stay sharp, and this is the BlackHat Path.